In earlier video, we explained about classification of hydrogen storage and compressed hydrogen in detail. In this video, we will explain about liquid hydrogen storage system. Hydrogen in its liquid form has much higher gravimetric and volumetric density compared with compressed gaseous storage. However, the technique to liquefy hydrogen is much more difficult and consumes more energy than the compression of hydrogen or the liquefaction of other conventional gases. Liquefaction is the process of converting a gas to a liquid by modifying its pressure and temperature conditions. Cryogenic temperatures are required for this process since the boiling point of hydrogen is -252.8 degrees Celsius at 1 atmosphere of pressure. Liquefaction process employs a combination of compressors, heat exchangers and expansion valves to achieve the necessary cooling. The simplest liquefaction process is the Lind's cycle or Joule-Thomson expansion cycle. During this process, the gas first undergoes isothermal compression, means the temperature of the gas stays the same throughout the compression process, at environment temperature, followed by cooling at a constant pressure in a heat exchanger, and then finally an isenthalpic expansion, refers to a process where a fluid like a gas or a liquid expands without gaining or losing heat. During the last stage, some of the gas liquefies and the remainder is recirculated through the heat exchanger before flowing back to the compressor to complete the cycle. The Lind's cycle works on gases, for example nitrogen, which cool as they expand at environment temperature. However, hydrogen heats up while expanding at environment temperature. To cool hydrogen as it expands, its temperature must be lower than its reversal temperature, -70 degrees Celsius. In order to achieve this temperature, the gaseous hydrogen is pre-cooled by evaporating liquid nitrogen to a temperature below -319 degrees Fahrenheit before the first expansion of the valve. Once the hydrogen has been liquefied, it is essential that it can be stored in such a way as to minimize evaporation. This evaporation of liquid hydrogen is not only a loss of the energy invested in liquefying the hydrogen, but also a loss of hydrogen in the long term, as the evaporated gas must be vented due to the pressure accumulated inside the storage vessel. This loss of stored hydrogen over time is known as boil-off and is reported as the percentage of stored hydrogen lost per day, the boil-off rate. The heat transference from the surroundings to the stored liquid hydrogen, LH2, and thus the boil-off rate is reduced by minimizing the surface-to-volume ratio of the vessels by making them spherical. LH2 vessels are usually double-walled with a gap between them. This gap minimizes heat transfer by conduction and convection. The space between the walls of the vessel may contain additional materials to prevent heat transfer by radiation. Owing to the high degree of insulation and the low surface-to-volume ratio, boil-off rates are very low in larger spherical tanks, usually below 0.1% per day. Thank you.